Okay, guys, this is going to be our first video, and I just want to make sure that we finish up our notes from yesterday. So here is where we were yesterday, and I was talking about how this chart can be used to determine the arms of the polynomial that you're going to draw. We're going to come up with this in a little bit. This is where we had left off, and I just want to quickly review that. There was this blue polynomial that was graphed beforehand, and we were writing factors for it. So notice that we had this plus 1 was actually, when we wrote it in its parentheses, it ended up being the opposite sign of the negative 1. Similarly with this positive 1, we had a minus 1 in the parentheses, and the same thing for the rest of these factors, for the rest of these numbers in the parentheses. And then we put these exponents, and the exponent was used, like a 2 was used here, because there was a bounce. The polynomial, the graph, the curve did not cross the x-axis. In fact, it just touched the x-axis and went back down again. But for all others, though, for all other x-intercepts, the graph just crosses through. It just goes completely through the x-axis. And we're going to illustrate this on the next page, but this is kind of where we left off yesterday. So first thing, example 5, we want to find the zeros and then sketch a graph of the function. So let's start with the zeros first. To find the zeros means that you're setting equals 0 and solving for x. So let's just make a little note here. This just means solve for x. Okay, so now let's go and find the zeros. Maybe you want to pause the video. Let's pause it actually and see if you can go in and factor this. Okay, I'm going to assume that you paused the video, so here's how you do the problem. Let's go and set this equal to 0 first of all. So we have negative 2x to the fourth, we have plus 16x squared, and minus 32. The first thing that I notice is I can take a negative 2 out of every single number. So if I do that, I get x to the fourth. And again, when I say take out, I'm dividing by negative 2. So divide 16 by negative 2, and I get minus 8x squared. And divide negative 32 by negative 2, and I get a plus 16. Okay, next, I think I can factor this part. I can do an old school method. So I need something times something equals 16. I also need something plus something equals negative 8. I'm able to do this because this is it looks like a quadratic. Even though it's x to the fourth, it looks like a quadratic. The number that I need here looks like it's going to be a negative 4 and a negative 4. Okay, so I can go in and keep going here, and I can say negative 2 here. I'll just break this part up. It's going to be x squared and x squared to get x to the fourth. So we basically break up that fourth power in half, so x squared and x squared. And then I have a minus 4 and a minus 4. All right. Now, these are actually a difference of two squares. I could actually factor these even more, and I'm going to. So now I have negative 2, and then I have an x squared minus 4 is going to be x plus 2 and x minus 2. And then for the second part, this part, I also have an x plus 2 and an x minus 2, because it's the same factor, it's just twice. Yeah, x squared minus 4 is the same thing as the one before it, so it's another x plus 2 and x minus 2. I could rewrite this, and I will. So negative 2, I have 2 x plus 2's, 1 and 2. So I have 2 x plus 2's, and I also have 2 x minus 2's. So let's go and take those 2 x minus 2's. Okay, this is what the polynomial factors to. And if we multiplied all this out, and I wouldn't recommend it, you would get where we started. So let's solve for x. Some people have asked in class yesterday, what happens if I take negative 2 and I set it equals 0? Well, it doesn't equal 0. So basically, if it's just a number in front of the parentheses and there's no variable in front of the parentheses, we ignore it. And we'll just go right down to the x plus 2 part. So let's set x plus 2 squared equal to 0. The way we're going to solve that is we can take the square root of both sides, and we'll get x plus 2 equals 0. So again, we just took the square root of both sides. And then we get x is equal to negative 2. So that's one answer. The second answer is going to be, again, set x minus 2 squared equal to 0 and take the square root of both sides. And I hope you find that you get an answer of x equals 2. Okay. Now to graph this. So now let me go and get a graph here. Let's look at the lead term. The lead term I'm going to find from the very, very beginning. And if you're not sure where, I'm going right here. Where is it? Not my highlighter. Going right here, negative 2x to the fourth. That's my lead term. And the way it works with this table here, I have all the table that you need here. The negative 2 is the lead coefficient. The 2 is negative. So it's going to be one of these two. I look at the degree, the exponent. If you didn't know what degree is, it's at the exponent. The exponent is even. So I'll just make a little note here that this is exponent. And the exponent is even, so it looks like I'm going to have exponent is even, lead coefficient is negative. I have these arms pointing down. Okay, that's my end behavior. And again, if you're not sure about that part, please pause the video and re-watch it so you can understand how I actually find the arms for this polynomial, because that's kind of the whole crux of the situation. Okay, so I have both arms pointing down. Okay, I'm going to put some steps here just so you know what they are when you're graphing. So to graph, 1, find end behavior. In other words, find the arms. So I'll just put in parentheses, find arms. Okay, step 2, plot your x-intercepts. Now the x-intercepts, what I mean by x-intercepts is the part that we found. So we found x equals negative 2 and x equals 2, so let's plot those. We have a negative 2 here, and we have a 2 there. These are actual points on the graph. Okay, next. Now let's go ahead and step 3, start drawing. But when you're drawing, look out for exponents on factors. For instance, when I approach the point, negative 2, because I know the graph has to go through negative 2, I have a decision to make. I can either bounce at the x-axis or I can pass through the x-axis. Now, how are you going to know? Well, you're going to know by the exponent of the factor. What's a factor? Great question. So this is the exponent of each factor. First factor is x plus 2, second factor is x minus 2. If you have an even power for a factor, you bounce. And at this point, we're going to bounce. And at 2, we're going to bounce. Why are we bouncing there? Because we had a factor of a 2 for each of those roots. And what we say is that that factor appeared 2 times. And we saw that the factor appeared 2 times. When a factor appears 2 times, what happens on the graph is the graph does not cross the x-axis. It bounces. So when I'm drawing my graph, I'm going to go ahead and bounce. Okay, so there's a little bounce. I didn't get to cross the x-axis because, again, that factor of x plus 2, so I'll just make a little note here that this is for x plus 2 squared. That little factor had an exponent of 2, so the graph bounced there. Now, it's going to have to come back up again. It has to come back up again because I have to get to this 2. So at some point, the graph is going to turn around, and I don't know where it's going to turn around. In fact, that's a calculus question. So I'll talk about that part in a second, but at some point, the graph is going to turn around and approach again the second x-intercept. We got this part from x minus 2 squared. This was x minus 2 squared. And again, the exponent is a 2 here. And the 2 causes the function to bounce again, the polynomial to bounce. So we're not going to cross through the x-axis. We'll just bounce again. and then we can connect the rest of the arms. This is how we draw the graph. There was one part that I said here, and again, please, 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 if you didn't get that part, go back and watch that again. There was one part that I said here that was kind of interesting, and I said, I have no idea where it turns here. I really don't. That's a calculus question. So what we have is a sketch. And as long as you have a bounce and the arms correct. So again, I'm looking for bounce, crossing through, and arms. I'm happy. You got to label your graph. You have to label the x-intercepts, but that's all I'm looking for. Bouncing or crossing and end behavior. That's all I'm looking for here. If you ask anybody outside of our class, we have a fancy word for the bouncing and crossing. We say that we are looking at the multiplicities. And it was on your notes from the last time, and I'm not going to use that word too often. I just need you to know about bouncing and crossing. But again, that's called multiplicities. I believe that's all I wanted to say for this video. Thanks for watching, and go ahead and watch the next video, please.